So the question is like the customer is using small subnets and they are facing IP limitations when scheduling the pods because the range is not having enough IP addresses to schedule the pods. So they are currently experimenting different CNIs, and then they're asking like what's the best strategy to use and how they can mitigate the issues like understand without recreating the cluster. So this is one of the common issues most of the customers usually face. They don't have enough IP address, and they also don't plan for growth when they initially create the clusters. So that was usually the customers continue with AWS VPC CNIs. Like there are like two ways you can fix this issue with AWS VPC CNI. So one of the common way to fix this issue is like using custom networking. The custom networking, I'll send you the link. So the custom networking allows you to additional secondary IP ranges to the existing subnets. So you can use either both. You can use either IPv4 or IPv6 range. You can assign it to the existing subnet, and then you can use that for the pod networking. So this range is non-routable. So this is routable within the cluster. So it's not routable outside the clusters. So you can use some /16 range that allows you to use separate IP ranges for your pod. So it's not consuming any range from the primary subnet. So the subnet range will be used for your nodes, and then the custom networking secondary subnets will be used for your pods. So this way you can scale your clusters without any issues. So also still you have some limitations on the 4,800 IP. So if you're running more than 4,000 nodes, so it will be similar problems. So definitely when you're creating a cluster, you need to plan for growth. If you want to optimize the IP address allocation at the node level without using the secondary subnet for custom network, you can use the IP prefix delegation. This addresses like how much IP how you can optimize the IP address allocation of the node level, but still it will be a problem because it still takes the IP address from the primary subnet. So I don't recommend prefix delegation because the amount of IP address you have is pretty limited. So go with the custom networking, then use the secondary CIDR for the pod. So if possible, if you can recreate the cluster, try to recreate the cluster and then use IPv6 instead of IPv4, so you have more IP addresses to use. Specific to Cilium, Cilium will be an alternative CNI. Definitely you can use that one instead of AWS VPC CNI, but there are like two limitations you need to be aware of. The first thing is only AWS supports only the AWS VPC CNI. So if you're having some problem, definitely you need to reach out to the open source community, or if you have some third-party support, you need to reach out to them. Also, if you are planning to run workloads in AWS EKS Fargate, then AWS VPC CNI is the only CNI supported. So you can't use a Cilium CNI for that one. So those are the two limitations with the Cilium. Also, when it comes to Cilium CNI, you can assign a specific prefix from the subnet at the node level. So you don't assign prefix for each CNI. You assign the prefix at the node level so that your pods can consume that one. So that way you can optimize how many IP addresses you can assign for each node. So definitely Cilium is recommended, but you need to remember about the limitations about the Fargate workloads. Apart from that, I don't see any specific issues with Cilium. I will also share another link where you can learn more about how the prefix, the subnet allocation works for the Cilium.